Alright guys, this video is for Algebra 2. It's 6.4, which is called nth roots. This video is going to probably be a little longer than most of them. There's a lot of different scenarios that we talk about, a lot of definitions, different things like that. The actual problems of these, though, is they're not difficult at all. It's more conceptual today with this video here than it is with actual problems. So we're going to go ahead and get started. You've probably heard me say, there we go. You've probably heard me say radical before. It's the main type of root. All right, you guys know square roots. Square roots, we've been doing for a long time now. Square root is a type of a radical. All right, so the radical is the general term. Square root is the specific term, or specific case for a radical. Now we're going to move on from square roots, and we're going to go on to bigger things such as cube roots, fourth roots, fifth roots, so on and so forth as we could. Probably won't go any bigger than fifth roots. So radical is another term for nth roots. A square root is the most commonly known one. And then your notation for these, make sure you know this bottom part right here. Your notation for nth root is n kind of sits here in this, I call it the seat of the radical. And then you have a big capital R down below. These two things have very specific names. I will say these when we're going over these in class. Make sure you know these. R is the radicand. So underneath the radical is called the radicand. And then this number out here, which may be a little weird to you guys, is called the index. Very important to understand what the index of a radical is. As far as we go forward, you haven't seen this yet unless you've worked with cube roots before. If you have, you've noticed there'll be a 3 here. That signifies a cube root. Square root doesn't have an index. It's assumed to be 2. So if you don't see it, it's a square root, and your index is 2. All right. So then the nth root, just like a square root undoes a square power, an nth root will be the inverse of the nth power, whatever that n power may be. So this slide here shows examples of that. So if a to the n equals b, then the nth root of b equals a. So 5 squared is 25, square root of 25 is 5. 7 cubed is 343, so there's the cube root for you. That's what it'll look like. The cube root of 343 equals 7. And then you have, 2 to the 9th equals 512, so the 9th root of 512 equals 2. Your calculator can also do different powers of roots if you look at it. If you hit math and you go down here, you can see if you go down past arrow frac, there's your third power, which we all know how to get there. There's specifically to a cube root. And this box here, you'll have to play with this. This is actually the first time I'm using this on a simulator, so I'm learning with you. But see, okay, so mine's going to be the old style. So I have to do it like this. So if I want to say I want to take the cube root of 81, okay, so then I have to go 3, math, arrow down, hit that, and that's going to put that 3 in the index. Okay, I think I said 81. I think that's a cube root. No, it's not. Anyways, so that's how you set it up. Okay, so if you don't have this, what you'll have if you just go into math and hit that button, like on my personal calculator, you'll see just 2 boxes, and then you can just arrow up to that box and put in 3, and then let me get one that actually works. Let's go 125. So I'll go 3 math, arrow down to 5. Yours, if you don't have it looking like this, you probably have a little square box here and underneath the radical, square box here and here, and then you can just do it right away. So you'll have to mess around with it. If you're not sure which one you got, show me in class. I can help you out. And then, boom, that tells you what the cube root is. So if you're not 100% positive, especially once you get into the bigger numbers, like if you have to take fourth roots, fifth roots, use your calculator to see if they're perfect or not. There are going to be, let me start this back up again. There are going to be roots I expect you to know fairly quickly, almost like the Mad Minute math you did in grade school. There's going to be one like that coming up at some point soon. So relatively quickly after we do this lesson, I'm going to expect you to know all of these, every single square root from 1 to 144. So your square roots of 1 through 12, and then your cube roots 1 through 6. So the cube root of 1, the cube root of 8, the cube root of 27, 64, 125, and 216. You'll have to know all of these memorized, and memorized. I'm not even joking with a minute time limit on this. That's going to be how the quiz is going to be set up. I don't know exactly when it's going to be. Ask me in class. I'll decide, and I'll let you know. I don't want to make it a pop quiz. That way you know it's coming. But I'll give you a time frame of when it could be. So make sure you get those memorized, because that's very important going forward. As far as the rest of this goes, one of the more complicated topics and confusing topics, to me at least, in this chapter is whenever you're simplifying. And that seems kind of backwards, because we've been simplifying for a long time. But take this under consideration. So when you're simplifying, what you're saying is that these two statements, these two mathematical sentences, are equivalent. They're the same thing. So you could have it the first way, you could have it the second way. And that gives you the exact same thing. So here's an example. I'm talking, let's say, the expression 2x plus x. Now, we all know if we say simplify it, we add those up, we get 3x. Great. Now, what you should be able to do then, if those are the same thing, you should be able to take numbers, one positive and negative, doesn't matter, plug them in and get same results. So that's what I'm going to do here, just to check, okay? So I'm going to take 5, plug it into 2x plus x. So 2 times 5 plus 5 gives me 15, and 3 times 5 gives me 15. Fantastic. Let's try a negative side just to get both ends. You do 2 times negative 4 plus negative 4 gives you negative 12. 3 times negative 4 gives you negative 12. Fantastic. Okay, so if that's the case, then we should be able to extrapolate that into the radicals. And this is what I'm kind of getting at here. So let's say you have the expression the square root of x squared. Now what we just talked about is that square roots cancel square powers. So logically speaking, this should simplify to x. Okay, cancel out the square. So then if we apply the logic up here that we applied to down here, we're going to be looking at different sides of numbers. So let's do a positive. So let's take 4. So 4 squared is 16. Square root of 16 is 4. Great. You plug in 4, you get 4. Fantastic. But if we go to the negatives, you have the square root of negative 9 quantity squared, which gives you the square root of 81, which gives you positive 9. But if you recall, we started with negative 9. So these did not give us the same thing. Okay? And the reason for that has to do with the fact that you cannot square root negative numbers. We still want to simplify it though, so to fix this, there's a special case where we're going to include absolute values in your answers to fix that case. I'm going to specify when I want to see them. The directions will say use absolute values when needed. And when you need them are for if you meet all 3 of these rules. So you need absolute values if you have an even index, an even power in your radicand, and you have an odd power coming out, as I say, or in your answer, one of the two. Okay, even index, even power in the radicand, odd power coming out of the radicand. You need to meet all 3 of these, even, odd. If you meet all of them, then you need the absolute values around that individual term. So we'll get to cases where you might need it around the x's, but you don't need it around the y's. I believe that'll be the next lesson, kind of. So you don't necessarily have to have it around just one. You could have it around the whole thing. You'll never have it around numbers. It'll be just your variables. Other than that, the rest of the lesson is all going to be examples of how to simplify these, and they're pretty relatively easy. So basically, you want to kind of work this so that you have the radical canceling out the power it should cancel out. So here's what I'm talking about. So number 1, we have plus or minus the square root of 16y to the 4th. The plus or minus just chills. It's going to take care of itself. A plus minus in front negates any absolute values you might need. You don't see it with me too often, usually just in the book. What you need to do is you need to rewrite the 16y to the 4th as an expression with a power of 2. Because the goal here is to get this radical to cancel out this square power. So you need to rewrite 16y to the 4th as an expression that gets squared. So basically you ask yourself, what squared gives me 16? Well, that'd be 4. What squared gives me y to the 4th? Well, that'd be y squared. The square root and the square power cancel, so you're left with plus or minus 4y squared. And that's your answer. That's the way I want you guys to think about these today. For this video, there is going to be different places where we can kind of take shortcuts. Notice how you had an even index, an even power, but you also had an even power on your answer, so no absolute values needed. Alright, number 2. The 5th root of 243, a to the 20th, b to the 25th. Okay, first off, notice you have an odd power, an odd index, so your absolute value bars are not needed whatsoever since you don't meet this one. Moving forward with that, you have 243, a to the 20th, and b to the 25th. So you want to rewrite all of that as an expression to the 5th power, and that would end up being 3. Come on now. A to the 4th, well, if I could write this morning. There we go. And b to the 5th. The 5th powers cancel the 5th roots, and so your answer becomes 3, a to the 4th, b to the 5th. Okay, remember you're simplifying these, so we're trying to make them smaller, we're trying to make it easier on us. Any signs, so number 3, any signs in front of your radicals when you're just simplifying, they're honestly just there to kind of mess with your head. You just want to drag them down along with you. And this is an example where these can be a little more confusing because of the exponents you have going on in the expressions, the multiple expressions. So you want to kind of rewrite it once again. You want to rewrite the inside expression as a power squared. So you don't mess with the x squared minus 6 part. You just figure out what power should go here, that when you multiply those two powers together using your power of power rule from chapter 5, gets you back to 8. So obviously that would be 4. So your answer is negative quantity x squared minus 6 to the 4th power. Hopefully you're noticing a pattern going on. We'll get more into detail about that later on. But yes, the pattern you are seeing is the pattern you can apply. If you don't know what that means, I'll tell you in class. So a couple more examples. We have 36x to the 10th. Be careful with this one here. So same process, you want to rewrite it as an expression that gets squared. So that'd be 6 x to the 5th, quantity squared, square root cancels the square power, so you get 6 x to the 5th. But notice here, you had an even index of 2, you had an even power inside the radical of 10, you have an odd power outside the radical of 5. So this is an example of the even, odd that we were talking about at the beginning. So this one, the x to the 5th, needs the absolute value bars around it. They have to be there. There'll be points off if they're not there. Number 5, same kind of setup. Take away, leave the negative, let it hang out. You leave the y plus 7 alone. You need the outside power to be squared, and the inside power is going to end up being 8. Since it needs to multiply to 16, so negative y plus 7 to the 8th power. Alright, so number 6, you have the 4th root of y. The 4th, kind of the same process here, rewriting it as, a power. So y to the 1st to the 4th, the main point of this example. So 4ths cancel, so you have y. Don't forget, just because there's no power when you write y, don't forget you have to check even, odd. So make sure that y gets in absolute value bars. They're tricky. You can kind of forget about them when you're working through a quiz or a test. And just kind of remember to check them. And remember, I'm going to say specifically when you need to show them. It's going to be very simple cases. So number 7, kind of picking up the pace just a little bit. Hopefully we're kind of getting the hang of it out there. So you have the square root of 6, y to the 3rd, all squared. The powers cancel. So there's another example of where you need absolute value bars because you start with an even index, an even power on the inside, and then an odd power on the outside. Alright, just a couple more examples. These can kind of throw people off because there's a lot going on with these of the lesson. I think these are probably your most complicated examples. You want to write the whole expression inside as a power. So for number 8, we have the 6th root of 64, x squared minus 3, all to the 18th. So you want to rewrite the whole thing as an expression that could be to the 6th, and that can kind of make your parentheses kind of get ugly. So here's what I do. I know that I want to rewrite everything as a big power of 6. I know that. And I know that 64, to rewrite that as a power of 6, it needs 2. Alright, so then I know the x squared minus 3, it doesn't change. And then on the x squared minus 3 term, I got one parenthesis out of place, don't I? Yes, I do. On the x squared minus 3 term, you need a power of 3 to make it 18. Alright, so see how that kind of works. You have this 2 to the 6th, x squared minus 3 to the 3rd to the 6th, all gives you that big power of 18. And then you're going to take the 6th root of all of that. The other way you could write it, just very quickly, you could do the 6th root of 2 to the 6th, x squared minus 3 to the 3rd to the 6th as well. You can it doesn't really matter either way, it kind of gets clustered kind of together either way. So whichever way makes the most sense to you. It's kind of just a confusing example to start with, and just kind of make sure you understand what you're trying to get accomplished. So you have 2 times x squared minus 3 to the 3rd. And where this gets messy is if you check these, you have an even index of 6, even index of 18, odd power on the parentheses coming out. So that expression of x squared minus 3 needs absolute values around it. So number 9, you have the 4th root of 2, x minus 3 to the 3rd, all to the 4th power, because that's what we're trying to get rid of. So you have 2 times the absolute value of x minus 3 cubed, and that simplifies to your answer. Alright, so then we got a word problem here to finish up with, finish off the lesson. So here we go. If c equals the 5th root of b squared, represents the number of collisions and B represents the number of bicycle riders per intersection. Estimate the number of collisions at an intersection that has 1,000 bicycle riders per week. If the total number of collisions reported in 1 week is 21, estimate the number of bicycle riders that pass through that intersection. So hopefully you notice it splits into two problems. The split is right there. So the first problem is pretty simple. It's saying 1,000 bike riders. We know that B is our bike riders, and we're trying to solve for C. So C equals the fifth root of 1,000 squared. This is where, like I showed you earlier on your calculator, that can come in handy. I don't want to drop, I'm not going to bounce back and forth between the drawing and the calculator, so I trust that you can figure that out. If you can't, let me know. So 15.85 is what you would get if in the calculator. And since we're talking about, bicycle collisions, you can't have 0.85 of collision, so we're going to go ahead and round that up to about 16. And then the other one, we're going the other way with it. So we're going to take 21 equals the fifth root of B squared. We're going to take a fifth power of both sides because that fifth power gets rid of that fifth root. So that gives you 4,084,101 equaling B squared, and then you take the square root of that, which gives you about 2,021 to equal B. So just to recap, over here, plug them in, square 1,000, take the fifth root of it. Over here, on this one, take a fifth power of both sides to get rid of the fifth root, and then take a square root to get rid of this square power. Now with that, guys, that's the end of this video. Your assignment for this one is going to be page 410, 12 through 34 even, 37, and 46.